All right, this is the last section of our Unit 3, and it's 10.5, making it decisions. So, does each statement describe experimental probability or theoretical probability? About 1 in every 60 products tested on an assembly line is defective. Well, that's experiment. There are 362 tickets in a draw, and 5 of these tickets will win. It's theoretical. All right, in 1950, Winnipeg had its 4th major flood in 200 years. Premier Duff Roblin wanted to build an expensive flood control waterway. Not everyone agreed. How did probability and subjective judgment play a role in the decision to build the Red River floodway? So subjective judgment is different from objective judgment. Oh man. A decision that is influenced by feelings rather than facts. So is each argument below based on experimental probability or subjective judgment or both? Building of the waterway will cost 63 mil. We need money for other things. We should not build the water. Subjective judgment. Big floods happen in 4 out of 200 or 2% of the year. We should not spend money on something that is so unlikely. Kind of both. Why can you not use theoretical probability to predict floods? So why? Because floods are caused by many factors. There might not be. Four floods in 200 years. In the next 200. Duff Roblin decided to build the floodway. Would you have made the same decision? Yes, I like Winnipeg. Yes, it's likely a flood will happen. So they did do a good job, I guess. Okay, let's do some examples here. We have Aaron. He's thinking of adding collision insurance when he renews his car insurance policy next year. This will increase the cost of insurance by $720 per year. Statistically, there is a 99.4% chance that Aaron will not have a collision in the next year. If Aaron has a collision, the insurance company will pay $5,000. Do you think he should do it? What is the probability that Aaron will have a collision in the next year? Well, let's see what... So this is what he won't, so let's see what he will. That's 0.6%. What is the expected gain for the company if Aaron adds collision insurance? Their gain is the probability of the gain times the gain amount minus probability of loss times loss amount. So the probability of the gain, they're going to gain if 99.4% of the time they're gaining $720 per year. Minus they only have 0.6% chance to lose 5,000. So that's $715.68 minus $30, $685.68. The expected gain for the company is $685.68. Should Aaron do it? Yes or no? I'll give you both. Whatever you want to put down, but you can put yes, if Aaron has an accident, he may not be able to afford to pay for the damage, or no, if Aaron is very unlikely to have an accident. Depends. Suppose that Aaron decides to add collision insurance. What is his expected loss? Oh, I guess you'd have to flip it. Well, I guess he would be losing 685, yeah, and gaining 30. Okay, number 1. Tanya tosses a coin to decide which of 2 microwave ovens to buy. The prices are the same. Tanya says there is a 50% chance of heads and 50% chance of tails. Is Tanya using theoretical probability, experimental probability, or subjective judgment? So, not driven by emotion, not driven by an experiment. It's theoretically 50-50. So theoretical. What assumptions is Tanya making about the microwave ovens? She assumes they're both equally the same. Assumes 2 ovens are equally good. That they're equally good. Okay. Practice number 2. So we have, was each decision made in the chart based on experimental, probability, theoretical, subjective, or a combo? I'll just put up the chart for you guys. So we know Brad knows that the odds in favor of being struck by lightning when you are out in the storm are about 575,000 to 1. During a bad storm, Brad decides to stay indoors. So that's theoretical probability and subjective judgment. Brad knows that being struck by lightning is unlikely, but it is still safer for him to stay indoors. Next one. In a trial shipment of 1,000 light bulbs, 3 are defective. Hannah decides to order more bulbs for the supplier. So that's an experimental probability. Experimental probability of getting a defective bulb is 3 in 1,000 or 0.003. Hannah expects that almost all the light bulbs she orders will work. And the last one, there are 1,200 tickets for raffle. Nayeli decides to buy 10 tickets to increase her chance of winning. Theoretical probability. The chance of winning is 1 in 1,200 with 1 ticket and 1 in 200 with 10. Okay, let's go on to Finn. Finn manages a restaurant in Edmonton. Last winter, he counted the nights the restaurant was busy after midnight. The odds in favor of being busy after midnight are 4 to 17. Finn wonders if he should close at midnight or 1:30 a.m. in the summer tourist season. What might Finn decide based on experimental probability? There are more than 4 times as many quiet nights as busy nights. Finn should close the restaurant at midnight. What assumptions might Finn be making if he uses only experimental probability to make the decision? Finn will be assuming that customer traffic in the summer is the same as it is in the winter. What might Finn decide if he uses subjective judgment? In the summer, there might be more customers at night. Finn might decide to stay open until 1:30 a.m. in the summer, but close earlier in fall and winter. Okay. Moving on to 4 then. We have, is there no practice in this part? Oh, that was practice. Okay. Okay, well, 4, I think you guys could do 4 and 5. So all you have to do, you look at big great earthquakes along the Castadian Fault. So just that happens about that much. So here's the dates. What is the experimental probability? So 1, 2, 3, 4, 5, 6. 6 out of how many years? Well, there's the years. So you have to divide that, get your percent. It costs more money to make structures safer for earthquakes. Should the builders in Cascade Fault spend this extra money, use probability, or okay, well that's just like, tell me the percent in your answer and use that as a subjective judgment to say they should or they shouldn't. Number 5, we have Denon is buying a clothes dryer that costs $825. It's got 1 year warranty from the manufacturer. The store sells 5-year extended warranty for $100. The odds against needing repairs are 3 to 17. What are the probability that the clothes dryer will need repairs during the extended warranty period? So I'll give you the formula. P is need repairs equals odds in favor over odds in favor plus odds against. So you got to put in the numbers and make that into a percent for me. What is the probability that the dryer will not need repairs? Well, you're just gonna take 100% minus what you got up here to give me the new percent. Okay. And then the company estimates that it costs $200 to repair a dryer. Suppose that Dennis buys a warranty. What is the expected gain for the store? That's just like the example we did earlier. So you should be able to follow that. And then should he buy? Tell me if he should or shouldn't. You can go either no or yes, but you need an explanation. And that is the brutal unit of probability and odds, unit 3. So next video, we'll be going into unit 4.